Okay, let's dive in. So picture this for a second. Imagine your essential services, your internet, right? Your cloud storage, maybe even how you charge your EV. What if those weren't owned by, the usual giant corporations?
Yeah, like owned by you.
And your community. Exactly. What if you could contribute, say, some spare computing power or put up a small piece of hardware and actually earn a real stake, like a tokenized share in that infrastructure?
That's not just some sci-fi idea anymore, is it? It's really the driving force behind this quiet revolution that's happening. We call them decentralized physical infrastructure networks. DePINs.
DePINs.
Right.
Because the old way, the traditional centralized infrastructure.
Well, it's got problems. Big ones.
Oh, absolutely. I mean, for decades, we've relied on this model, what we call CI, critical infrastructure. And the sources we looked at are pretty clear. That old model is kind of brittle, it's inefficient.
Yeah, the critiques are pretty compelling when you lay them out. I mean, think about the cost. Building traditional infrastructure needs huge amounts of capital up front.
Yep.
CapEx, right? Exactly. Massive CapEx, which basically locks out anyone but the biggest players. And beyond the cost, there's just this fundamental lack of resilience. We see it all the time.
Single points of failure everywhere makes the whole system, even the web itself, feel kind of fragile.
And that centralization, it leads to what you might call unnecessary value extraction. Think about like ride-sharing apps in Web 2. The platform itself doesn't own the cars or do the driving, right? It just connects people.
Yeah.
But it takes a pretty hefty cut just for playing matchmaker.
Yeah, for that trustless coordination bit.
Right. And our sources really emphasize this point. People often confuse that with like genuine sharing or co-ownership, but it's not. It's mostly just access. You're renting time or space. You're not building any real equity.
That's a really key difference, isn't it? And it kind of frames this whole deep dive. Because when you apply that thinking to something like, say, centralized cloud storage, the problems just jump out.
They really do. It's not just about the web being fragile. It actually hits privacy hard, too. Your data. Often stored unencrypted or with keys the provider controls, not you.
Not ideal.
Not at all. And because a few big companies dominate the market, there's less competition, which means prices for storage stay, well, artificially high.
Okay, so that sets the stage. This whole fragile, expensive, not very private system. That's what DePINs are trying to fix.
Precisely. DePINs are essentially merging physical infrastructure, like actual hardware, with blockchain technology. They're applying Web3 ideas, those principles of decentralization, to tangible, real-world assets.
So how does that work practically?
Well, the system basically distributes everything, decision-making, managing the resources, controlling the network across this huge web of interconnected nodes. And these nodes are independent, they're sovereign.
Okay.
And the engine driving it all is this concept called proof of physical work. It sounds techie, but it's basically a way to directly link digital finance, like tokens, with providing real everyday value, like running that server or providing that coverage.
So the goal is
What?
more robust systems. Cheaper.
All of the above, hopefully. More resilient, definitely. More efficient. And crucially, systems that are actually owned by the community that uses them.
All right. Let's get into the weeds a bit then. What exactly is a DePIN? I mean, it sounds like we're talking about permanently linking, I don't know, steel and concrete and silicon chips to a digital ledger. Is that it?
That's a big part of it, yeah. But the definition of physical infrastructure itself is kind of evolving here.
How so?
Well, because what our economy depends on is changing, right? So fundamentally, a DePIN is a network that uses crypto incentives tokens, usually to coordinate how underlying infrastructure operates efficiently.
Okay.
And the key thing the sources point out is that infrastructure here isn't just roads and bridges anymore. It's heavily focused on these crucial service networks. Think telecom, cloud storage, compute power, the digital plumbing of modern society.
Oh, right. The stuff we actually use constantly. So DePINs are decentralizing the coordination of those services.
Exactly. And there are sort of three core pieces that make this whole thing tick. First, you absolutely need the blockchain.
The blockchain is the foundation, right?
Right.
The ledger.
Correct. That gives you the secure, transparent, unchangeable record you need to track who's contributing what, manage the token rewards fairly, and make sure the governance, how the network is run, is open and auditable.
Makes sense. What's number two?
Number two is the tokenized incentives. This is really the engine. It's how you reward the people who actually contribute the physical resources. You deploy a wireless node for Helium. You share your spare hard drive space for Filecoin. You get paid in the network's own crypto tokens.
Okay, so the blockchain tracks it. The tokens reward it. What's the third piece?
The third piece connects it all back to the wider crypto world. integration with DeFi or decentralized finance.
Ah, okay. Like staking and stuff.
Exactly like staking. Projects use DeFi tools pretty strategically. Staking, where people lock up tokens, is a big one. It encourages long-term commitment, helps stabilize the network, and drives this kind of organic, self-sustaining growth.
So operationally, this is a massive shift, isn't it? From one big company running the show to what?
To basically a decentralized resource ecosystem. Think of it like a two-sided marketplace. On one side, you've got users with valuable resources that are just sitting idle, spare storage space, unused internet bandwidth, maybe even GPU power.
Right. Wasted capacity.
Totally. And on the other side, you have users who need those resources. The DePIN connects them. But crucially, instead of needing a big corporation in the middle to handle the transaction and take a cut,
The smart contract handles it. Trustlessly.
precisely, the coordination is automated, transparent, and built into the code.
Okay, let's compare that financially. Centralized infrastructure. We already said. Massive upfront capex. Building a new data center or a cell tower costs a fortune.
A fortune, yeah. And it's rigid. You commit that capital and it's sunk. DePINs, they kind of sidestep that whole problem. They operate with what you could call a fluid cost base, especially for the suppliers, the people providing the resources. Because the contributions are spread across maybe thousands of individuals, the network itself doesn't face that crippling upfront capex. And the ongoing operational costs, the OPEX, are way lower too.
And that cost difference is what makes it viable for regular people to participate, to run a node from home or something.
Exactly. It democratizes the supply side. Suddenly, running a small node can actually be economically worthwhile for an individual, not just a giant corporation.
Okay, but hang on. If you've got thousands of random people running nodes, how do you guarantee quality? How do you make sure, Bob's spare hard drive connected in his basement offers the same reliability or speed, the quality of service as a massive purpose-built Amazon server farm? That seems like a potential nightmare for quality control.
That's a really sharp question, and it gets right to the core of the engineering challenge, yeah. It's also why this idea of resilience is so central to DePINs.
Okay, resilience versus what's just being strong.
Yeah, kind of. Centralized systems are often strong, robust, yeah, but they're monolithic, they're rigid. If one big critical component fails, like a major data center goes offline, the whole service can potentially collapse.
All right, single point of failure again.
Exactly. Decentralization flips that. By distributing control across all those nodes, the system becomes inherently more flexible. It builds in redundancy. It can adapt. Our sources actually link this to something called complex adaptive systems theory, CAS theory.
CAS theory, right. The idea that systems with lots of interconnected, self-organizing parts are better at handling shocks and changing conditions.
That's the one. The network as a whole becomes much better at handling stress or expanding its capacity when needed. Why? Because the decision-making, or at least the response, happens much closer to where the problem is if one node goes down.
There are plenty of others to pick up the slack immediately.
Instantly. And that's true resilience, which is maybe a step beyond just robustness. Now, how they ensure Bob's node is performing well? That comes down to the technical checks, the proof mechanisms we should probably get into. They're constantly auditing performance and, crucially, penalizing nodes that don't meet the standards.
Okay, let's shift gears then to the engine room, as you say, because this is where I think a lot of the skepticism lies. In a centralized world, the company guarantees the quality. They have SLAs, support teams, all that. How on earth do these decentralized networks prove that the work is actually being done correctly in the physical world?
Yeah.
You can't just take someone's word for it that they deployed a server or that their hotspot is really covering the area they claim.
No, you absolutely cannot. And that's the entire point of these specific consensus mechanisms. They all kind of fall under this umbrella term, proof of physical work.
Proof of physical work, okay.
Yeah, and these aren't just about tracking crypto transactions like Bitcoin's proof of work. These are really clever, cryptographically verifiable systems designed specifically to measure the actual delivery of some real-world utility or service. They essentially turn a physical action into digital proof you can trust.
Okay, that sounds cool. Can we look at some examples? How does this auditing actually happen?
Definitely. Let's take 3 different types to illustrate. First up, maybe the most famous one, proof of coverage or pay-as-see. This is what the Helium network uses.
Helium, right. The decentralized wireless network.
Exactly. So Helium needs to know not just that someone has plugged into one of their hotspots, but that it's where they say it is, it's configured correctly, and it's actually providing the wireless coverage it's supposed to.
So how do they check that? Does someone drive around with a signal meter?
No, much cleverer than that. Proof of coverage works by having nearby hotspots basically challenge each other. One hotspot sends out a cryptographic challenge, and the target hotspot has to respond in a way that proves its location and its radio performance in that specific spot.
Ah, okay. So it's like the network is constantly self-auditing through these challenges, not just a self-declaration. It's an interactive, location-verified test.
Precisely. And this is critical, right? Because it incentivizes people to deploy hotspots where they're actually needed in areas with poor coverage rather than just clustering them all together in one convenient place.
Right.
The network rewards verified coverage, which aligns the incentives with building out useful infrastructure.
Okay, that makes sense for wireless. What about something like compute power, especially high-performance stuff like for AI or rendering,
Yeah.
where you need guaranteed low latency?
Good question. Let's look at Ether. They're doing GPU as a service, basically renting out powerful graphics processing units. They use something called proof of rendering capacity.
Proof of rendering capacity. How's that do?
Well, Ether splits its global network into these regional sidechains. They call them session zones. This takes pressure off the main blockchain, helps keep things fast. The core proof mechanism here isn't just verifying that the GPU hardware exists, but it's checking its real-time processing capacity and its availability. Like, is it ready to work right now?
Who does the checking?
They have validator nodes. These are participants who have staked Ether's token, putting skin in the game. They get randomly selected to audit the performance of the GPU providers. If they verify correctly, they get consensus rewards. This system helps ensure Ether can actually deliver the high-performance, low-latency service needed for demanding stuff like cloud gaming or AI model training.
Right. Enterprise-level use cases need those guarantees. Okay, one more. What about mapping? You mentioned Hivemapper earlier, collecting street-level imagery. How do they ensure the data they get from dash cams is real and accurate?
Yeah.
Someone could just fake GPS data, couldn't they?
They could try, which is why Hivemapper uses what they call proof of locations, and it's pretty sophisticated. It's actually a 3-layered verification system.
3 layers. Okay.
Yep. Layer 1 is standard GPS data from the dash cam, but that's not enough on its own. Layer 2 uses Helium's LoRaWAN network, that same wireless network we just talked about, as a secondary check for location redundancy. It basically cross-references.
Okay, GPS plus helium. What's the third layer?
The third layer is post-collection quality assurance. They call it Map Image QA. This involves both AI algorithms and human reviewers looking at the actual imagery collected to check for anomalies, quality issues, and consistency. It helps filter out bad or fraudulent data.
Wow, okay, so it's quite a robust process. GPS, a secondary network check, and then actual image review.
Exactly. That multi-layered approach is crucial for protecting the integrity of the map data, which has to be trustworthy if people are going to rely on it.
And this focus across all these examples on proving utility, proving that real measurable work got done, that seems to be the key driver for the tokenomics and DePINs, right?
Absolutely. It's fundamental. Unlike maybe some purely speculative crypto assets, DePIN tokens generally have strong inherent utility. This creates organic demand for the token itself.
How so?
Well, take Filecoin again. If you want to rent storage space on the Filecoin network, you have to pay for it using a File tokens. It's the only accepted currency within that ecosystem.
Ah, right. So the demand for the service storing files directly translates into demand for the token needed to pay for that service. It's not just about hoping the price goes up.
Precisely. The need for the token is baked into the network's core function. It's the native currency of that specific digital economy. And that structure, that link to real-world utility, makes these tokens potentially more suitable for sustainable long-term growth because their value is actually underpinned by demand for a physical service.
Okay, but designing these token economies, it sounds tricky. Projects face this balancing act, don't they? You need strong incentives at the beginning to get people to join and build out the network, bootstrap it. But if you give away too many tokens too early, you risk diluting the value for everyone later on.
That's the classic dilemma. And our sources break down sort of 3 main approaches to how projects handle token issuance, how they release new tokens into circulation.
What are they?
The first one is time-based issuance. This is often used early on. You basically release a set amount of tokens over a fixed schedule. It provides strong, predictable incentives up front, which is great for getting that initial network effect going.
But what's the downside?
The big critique here is the risk of something called manufacturer extractable value, or MEV. Not the same MEV as in DeFi block building, but similar idea. Here, the manufacturer might be the hardware provider or the initial token issuer. If the network rewards the very first participants too generously, and those early birds are often closely tied to the project creators or hardware makers.
They can just accumulate a massive amount of tokens cheaply and then dump them on the market later, undermining the price.
Exactly. That early rush of rewards can come at the cost of long-term price stability or create opportunities for early insiders to extract disproportionate value.
Okay, so time-based is good for starting, but risky long-term. What's the second approach?
Second is supply-based issuance. This tries to balance the token price against the growth in supply. You might set fixed issuance limits tied to certain milestones like release X tokens once the network reaches Y capacity. It offers a bit more certainty than pure time-based, but it's less responsive to actual market demand.
Right, it's still kind of pre-programmed.
Yeah, which leads to the third approach, which many argue is the most efficient for long-term health, demand-based issuance.
Demand-based. So tokens are only created when? What?
Yeah.
People are actually using the network.
Pretty much. This model directly ties the creation of new tokens issuance to the actual usage or revenue generation of the network. Tokens might only be minted when demand for the service is high, or maybe they're minted to match tokens being burned through usage fees.
That sounds ideal for preventing dilution, right? Supply only increases when demand is proven.
It is great for preventing dilution,
Yeah.
but it has a massive cold start problem.
Because if it's a brand new network, there is no demand yet.
Exactly. So if tokens are only issued when there's demand, but there's no demand initially, then there are no incentives for the first wave of crucial contributors to even show up and build the supply side. It's a catch-22.
So demand-based is good for mature networks, but terrible for new ones.
Pretty much. Which is why, in reality, most successful DePIN projects use a combination of these methods. Maybe they start with some time-based rewards to bootstrap, then transition to supply-based as they hit milestones, and eventually aim for a demand-based model once the network is established. A kind of phased approach.
Makes sense.
Yeah.
And to make sure these contributors, the node operators, are actually committed. I mean, they need skin in the game, right?
Yeah.
How do the incentive models ensure that? Does it differ depending on what they're contributing?
It does, yeah. The models tend to vary based on the type of resource being provided. For what we call digital resource networks, or DRNs, think compute power, bandwidth, things that don't necessarily require huge physical hardware purchases.
Right. Maybe just software or using existing capacity.
Yeah. For those, the primary model is often stake for access. You have to lock up or stake a certain amount of the network's token to even be eligible to participate and earn rewards. That stake acts as collateral, ensuring good behavior.
Okay, stake to play. What about the networks requiring actual expensive hardware, like buying a Helium hotspot or a powerful GPU for Ether?
Those are physical resource networks, or PRNs, and because they require a significant upfront investment from the contributor, they often use a node purchase model, especially early on.
Node purchase, like you buy the hardware and that's your buy-in.
Sometimes you buy the hardware directly, yes. But increasingly, especially in 2024, we saw projects like Ether or Impossible Cloud actually selling node licenses before their token even launched. Early supporters buy the right to operate a node and earn future tokens.
So that serves two purposes. It gets early commitment and also helps fund the project's initial development. Covers that CapEx we talked about.
Exactly. It aligns incentives right from the start and provides crucial early funding.
We're also starting to see some newer ideas around curation mechanisms, aren't we? Ways to make sure the network resources actually get deployed where they're most needed using local knowledge.
Yeah, this is really interesting stuff. It tackles the problem that just having decentralized resources isn't enough. You need them allocated efficiently. How do you ensure nodes pop up in underserved areas, not just wealthy suburbs?
Right. How do you use local expertise?
Well, one way is through stake-based curation. Imagine participants staking tokens not just generally, but in a specific geographic area. Doing so might earn them special status, like medallions in the Dawn network example, which could unlock higher rewards multipliers for users in that specific zone.
And the staker gets.
The staker, acting as a local curator, gets a share of the revenue generated from that specific location. It incentivizes people with local knowledge to basically act as market makers, directing resources where they know demand exists or coverage is poor.
So it leverages local insight, which purely centralized systems often miss.
Totally. We're also seeing NFT-based curation models. Nadix Network has island NFTs, for example. People buy an NFT representing a specific geographic tile, and they get a share of the data revenue generated from that tile. Again, it's about using financial incentives to harness distributed local knowledge for better network efficiency.
Okay, so we've got the theory, the mechanics, the incentives. Let's talk impact. applying this decentralization across different industries. This is where DePINs stop being just a cool concept and start becoming, well, potentially transformative operational models, right?
Absolutely. This is where the rubber meets the road. And maybe the most urgent, timely application right now is in decentralized compute, largely thanks to the absolute explosion in AI.
Yeah, the demand for GPUs is just insane, isn't it? Complex AI models like ChatGPT, all the large language models, they're incredibly power hungry.
Insanely power hungry has caused these massive ongoing GPU shortages. Prices have gone through the roof. Traditional data centers, even the hyperscalers, are struggling to keep up. And honestly, the way AI workloads are developing, they need a more distributed, flexible infrastructure anyway, not these giant monolithic stacks.
Which brings us back to Ether,
Mm.
offering that GPU as a service we mentioned. Their core idea tackles a huge inefficiency, doesn't it?
A staggering inefficiency. They focus on pooling GPUs that are currently unused or seriously underutilized, mainly within existing data centers and large enterprises.
And the statistic there was.
Yeah, it's pretty shocking. The average data center in the US, according to the sources, might only be using something like 10% to 15% of its installed GPU capacity at any given time.
Wow. So 85, 90% of that incredibly expensive hardware is just sitting idle.
A massive amount, yeah, just stranded assets. Ether basically provides the coordination layer, the DePIN, to unlock that value.
So they're not necessarily building new GPU farms, but making existing ones usable.
Primarily, yes. By pooling these idle resources, their projections suggest they could potentially multiply the world's available GPU processing power by more than 10 times. That's huge.
10 times. And they claim a big infrastructure lead.
They do. Reports suggest they have something like 20 times more GPUs available on their network compared to competitors like the Render network. The goal here is to break that AI infrastructure bottleneck, give more people access to powerful compute, and also reduce the massive financial risk companies face having to constantly buy the latest, greatest multi-million-dollar hardware.
And we're seeing real demand across this decentralized compute space, aren't we? It's not just Aether.
Oh, definitely not. You've got Render Network, which focuses specifically on peer-to-peer GPU rendering for graphics and visual effects. You've got LivePeer doing decentralized video transcoding, basically reformatting video for different devices, and they claim they can do it up to 50 times cheaper than traditional cloud providers.
50 times cheaper.
Wow. Yeah. And then there's Akash Network. They run a peer-to-peer cloud marketplace for compute. They reported revenues of $2.5 million in 2024, saw demand for GPUs on their platform grow by something like 33 times, supporting over 400 specialized AI chips.
Okay, those numbers are pretty convincing. The market seems to be voting with its feet, or its dollars, for these decentralized compute solutions.
It really does seem that way. The demand is clearly there.
All right, let's shift from compute to decentralized storage. This tackles those issues we mentioned earlier, data resilience, privacy, maybe even digital permanence. Filecoin is probably the biggest name here.
Filecoin is definitely a major player. The model is straightforward. Users pay in FIL tokens to have their data stored, not on one central server, but redundantly across many independent storage providers, nodes, all over the world.
And the benefit is faster access, more reliable.
Both, potentially. Data can often be retrieved from the node geographically closest to the user, which can speed things up. And the redundancy makes it incredibly resilient. If one storage provider goes offline, your data is still safe on many others. But the real magic, I think, happens when you combine Filecoin with protocols like IPFS.
IPFS, the Interplanetary File System. You mentioned this changes how we find information online.
Fundamentally, traditional web links point to a location, get the file at this specific server address. If that server moves or the file is deleted, the link breaks. You get that 404 not found error.
We've all seen that.
Annoying. Can be more than annoying. IPFS changes it to a content addressed model. It asks, find the file that has this specific content, identified by its unique cryptographic hash, like a digital fingerprint.
So it doesn't matter where the file is stored as long as a copy exists somewhere on the network.
Exactly. You're asking for the what, not the where. The implications for things like preventing link rot are massive. You mentioned that Harvard study nearly half the links in U.S. Supreme Court opinions are dead. That's a serious problem for historical record keeping.
Yeah, that's shocking. Because the moment a company changes its website structure or a server goes down, poof, the data is gone or the link is broken.
But with IPFS and a DePIN storage layer like Filecoin providing the persistence, if one node holding the file disappears, the network can just retrieve it instantly from any other node that has a copy. It provides much stronger guarantees around digital permanence. It makes the web less brittle.
Are there other players in decentralized storage besides Filecoin?
Oh, yes. Storage is another well-known one. They also offer decentralized cloud storage, often highlighting their environmental angle. They focus on utilizing existing spare hard drive capacity rather than requiring people to buy specialized new hardware.
Okay, more of a software-based approach.
Yeah, kind of, yeah. Their token, SDRJ, has seen volatility like many cryptos, but the project continues to operate. And you still have legacy players like BitTorrent, which, while older, operates on similar principles, a decentralized network rewarding users, in BTT tokens, for sharing files, seeding data for others to download.
Right. Okay, third major area, data collection, mapping, and mobility. Hivemapper comes up again here as a prime example of incentivizing everyday people to contribute.
Hivemapper is fascinating. Built on the Solana blockchain, it basically pays people drivers with dash cams, but also AI trainers who review the data, and even just mobile app users contributing sensor data to capture and process real-world footage.
And the goal is to build a global map, like a decentralized Google map.
Essentially, yes, a constantly updated, highly detailed global map built collaboratively from the ground up rather than relying only on expensive survey vehicles run by a few big companies.
And we already talked about their proof of location system, ensuring the data quality.
Right, that three-layered check is vital for trust. This model supports applications built on top, like their BMaps app, and it addresses issues like the lag time you often see in updates on centralized maps. Plus, the contributors actually get paid for the valuable data they generate.
What about connectivity, IoT and stuff?
Yeah, there are DePINs focused on that too. Chirp Network is building a decentralized telecom network specifically for the Internet of Things. Low power, wide area stuff. They even launched a game on the SUI network called Cage.
A game? How does that fit in?
It's a DePIN P2E play-to-earn game. Users basically earn SharePay tokens by using their phones to physically scan for wireless networks around them. This crowdsources data to build out a global geolocation database, which is apparently really useful for things like indoor navigation where GPS doesn't work well.
Huh. Gamifying network mapping. Clever. And mobility generally seems ripe for DePINs.
Definitely. We're seeing projects tackle ride-sharing, like Drive.io, which is active in Dubai, aiming to give drivers a bigger cut. There's smart city traffic management. Atlas Navi uses AI and driver data to create real-time digital twins of road networks. EV charging is another area, Charge.xyz working on accessibility.
And Demo. That one seems very direct.
Yeah, Demo lets car owners connect a device to their vehicle, collect their own driving data performance, location, diagnostics, that kind of thing, and then choose to monetize it if they want, giving control back to the owner over data that automakers currently keep locked up in proprietary systems.
Okay, one last application area from the outline, shared ownership and energy. This really bridges the physical and digital divide using DLT to manage shared assets. Let's revisit that example of Anna, Bia, and Charlie wanting to co-own an electric car.
Right. In the old world, trying to manage that between three people who maybe don't know each other well, it's a nightmare.
You'd need lawyers, contracts, maybe a management company.
Exactly. Loads of overhead. You'd need someone to handle risk assessments, check finances, figure out who pays for maintenance when, track who used the car how much, enforce rules. The coordination cost, that intermediary expense, would likely kill the whole idea before it started.
But with DLT, with a smart contract,
the complexity just kind of dissolves. The smart contract can automatically partition ownership into tokenized shares representing each person's stake. It can manage a booking calendar autonomously. It can track usage quotas, maybe disable the car's key fob access once someone hits their monthly limit.
automatically.
Yep. Send automated reminders when maintenance is due based on mileage data. And importantly, it can enforce rules transparently. If someone misuses the car or misses a payment, the contract could automatically reduce their usage allowance the next month. Instant automated accountability.
Wow. So DLT makes these complex multi-party ownership models actually feasible by slashing those coordination costs. It enables real communal ownership, not just renting access.
Precisely. And that same principle, reducing coordination costs to enable decentralized systems, is having a huge impact on the energy sector too, specifically with the rise of microgrids.
Microgrids, these are like small, local energy networks.
Exactly. Small, often self-contained energy systems. They frequently use renewable sources like local solar panels. The Brooklyn Microgrid project is often cited as a key example. It showed how a local community could actually generate its own renewable energy and manage the distribution within their neighborhood, peer-to-peer.
And the benefit there is Resilience, like if the main power grid goes down.
Resilience is a huge one, yeah. Microgrids can potentially island themselves and keep running during wider blackouts, but it's also about community empowerment. People become prosumers, they both produce and consume energy, they have more control, potentially lower costs, and a direct stake in their local energy system.
Is this a niche thing or is it growing?
No. It's growing fast. The sources project the global microgrid market could hit something like $168 billion by 2032. That's a pretty significant shift towards more decentralized, localized energy infrastructure.
Okay, so we painted a pretty compelling picture here. Decentralized compute, storage, mapping, energy, ownership. The potential seems enormous, but it can't all be smooth sailing, right? What does this all mean practically? What are the big hurdles, the challenges facing DePINs right now? Because this is still a pretty young industry.
Oh, absolutely. It's definitely not mature yet, and the challenges are significant. They really fall into a few buckets: technical, economic, and regulatory, although we have some news there.
Let's start with the technical and operational hurdles. What's top of the list?
Scalability is almost always mentioned first. As these networks grow, potentially to millions of nodes contributing data or resources, just managing that complexity is tough. Can the underlying blockchain handle the transaction volume efficiently? Can the network ingest and process all that data without getting bogged down? It's a major engineering challenge.
Okay, scaling issues. What else?
Then there's that cold start problem we touched on earlier. For any new DePIN project, how do you convince the first wave of people to contribute their hardware, their time, their capital before the network actually has much proven value or utility?
Right. The chicken and egg problem. You need suppliers to attract users.
Yeah.
But you need users to attract suppliers.
No.
If I buy that Hivemapper dash cam, I need some confidence that people will actually want the map data I collect, so I get rewarded.
Exactly. Bootstrapping that initial supply and demand is really tricky. Another practical issue, especially for storage, can be data retrieval speed.
Yeah. You mentioned this. While decentralization adds resilience, it might not always be as fast as a highly optimized centralized data center.
Potentially, yeah. Retrouting data that's split across many different nodes, maybe with varying connection speeds, can sometimes introduce latency compared to grabbing it from one big, fast server. This might make current DePIN and storage less ideal for applications needing absolutely instantaneous, high-frequency data access. Think maybe real-time financial trading or serving core assets for a high-traffic website.
Okay, so performance trade-offs in some cases. What about accountability? This one worries me, especially for critical infrastructure. If my decentralized internet service goes out, who do I call? Who's responsible?
That is a huge question and a real friction point. In a traditional model, you have a company with a service level agreement, a customer support number, maybe even legal liabilities. In a fully decentralized network of thousands of independent, often anonymous node operators, who is accountable?
Right. There's no CEO to complain to.
Exactly. This concern about no accountability is real. The current DePIN answer relies heavily on economic incentives and penalties built into the protocol. Nodes that fail performance checks or misbehave get their staked tokens slashed, taken away, or they simply don't receive rewards.
So bad actors lose money. That's the enforcement mechanism.
Primarily, yes. It creates a strong financial incentive to provide good service, but it doesn't really replace traditional legal recourse or provide a clear path for resolving complex disputes. That's a barrier, especially for getting big, conservative enterprises to rely on these networks for mission-critical stuff.
Okay, let's switch to the economic challenges then. The big one seems obvious. Token volatility.
Huge one. If you're running a node, say, providing storage and your costs are in regular dollars, for electricity, hardware maintenance, but your revenue, your rewards, are paid in a crypto token whose price swings wildly. How do you run a sustainable business?
Yeah, it makes planning impossible. Doesn't that risk just completely destabilizing the network if the token price crashes? People might just switch off their nodes if it's not profitable anymore.
It absolutely does. It can crush motivation and lead to supply-side churn. This is why sophisticated tokenomics design is so vital. We're seeing more projects try to tackle this directly using mechanisms like that burn and mint equilibrium model you hear about.
Burn and mint. How does that help stabilize things?
The basic idea is to try and peg the token's value, or at least its purchasing power within the network, more closely to actual utility. You might burn tokens that are collected as usage fees, reducing supply when demand is high, and then mint new tokens as rewards for suppliers, increasing supply based on contribution. By dynamically adjusting supply based on demand and usage, you hope to create a more stable internal economy for the token, less susceptible to purely external market speculation.
Okay, so engineering more stability into the token itself.
Yeah.
But even with stable tokens, there's still the initial investment cost, right? Someone has to buy the hardware even if it's distributed.
Correct. Even if the network avoids massive centralized capex, the collective cost of all those individual nodes, dash cams, hotspots, hard drives, GPUs still needs to be funded somehow. Setting up the physical side of a DePIN can still require significant upfront capital, whether from VCs, token presales, or the node operators themselves. And it can take time before the network reaches enough scale and generates enough demand to provide a return on that investment. That's a hurdle purely digital Web3 projects don't really face in the same way.
And finally, maybe the simplest but biggest challenge, just getting regular people to use this stuff. User adoption.
Yeah. At the end of the day, that's key. The tech can be brilliant, but if it's too complicated or niche, it won't reach mainstream traction. Right now, interacting directly with blockchains, managing crypto wallets, staking tokens, it's still quite complex for the average person.
Most people just want an app that works, right? They don't want to think about the underlying infrastructure, centralized or decentralized.
Exactly. So a big challenge for DePINs is creating really user-friendly applications and interfaces that abstract away all that blockchain complexity, making it as easy to use a decentralized service as it is to use its Web2 counterpart. That friction needs to be smoothed out for mass adoption.
Okay, so lots of challenges. But you mentioned some positive news on the regulatory front. That's often a major hurdle for crypto projects.
It is, and this was actually a significant development. On September 29th, the U.S. Securities and Exchange Commission, the SEC, issued what's called a no-action letter.
A no-action letter. What does that mean?
It essentially means the SEC staff reviewed a specific proposal, in this case, related to certain DePIN tokens and stated they would not recommend enforcement action. The key finding was that these specific tokens, when used purely to incentivize participation in decentralized networks for things like wireless coverage, energy, or mobility.
The core DePIN use cases we've been talking about.
Right. When those tokens function primarily as utility within the network and aren't offered or sold as investment contracts promising profit based on the efforts of others, which is part of the Howey test for securities, then they fall outside the SEC's jurisdiction as securities.
Wow. So the SEC basically said these specific DePIN utility tokens aren't securities.
For the cases reviewed, yes. It signals a potentially broader deregulatory stance, or at least more clarity, specifically for utility-focused DePINs. And that clarity is huge. It removes a major cloud of uncertainty that was likely holding back more traditional financial institutions and large companies from getting involved in the space. It's a big win for the sector's legitimacy and potential growth.
That is big news. Okay, but before we wrap up, let's touch on that critical counterpoint you raised. DLT enables all these cool new ownership models, like the shared EV, but we need to be careful about what we apply it to. You used fractionalized home ownership as a cautionary tale. Why isn't digitally slicing up houses a good idea?
Because, fundamentally, technology is just a tool, and we have to think about the societal consequences of how we use powerful tools like DLT. While you can digitally represent fractional ownership of a physical house on a blockchain, you run into a hard physical limit.
Which is?
The actual right to live in the house, the right of physical occupancy, cannot be meaningfully fractionalized. I mean, you can't have 100 different digital owners trying to physically occupy 1% of the living room each.
No, that doesn't work. So what happens instead?
What happens is it risks turning primary housing into something more like a financial asset or a timeshare. Large investment pools might buy up fractions of many homes purely for yield, removing that housing stock from the regular market where people are looking for a place to actually live.
So it concentrates ownership value for existing owners and investors,
Right?
but makes it harder for regular people to buy a home.
That's the major concern highlighted in the sources. It could remove affordable housing, turn residency into this managed short-term occupancy thing, and further separate the possibility of home ownership from average income individuals. They call it a ratcheting effect. The financialization just keeps pushing prices up, making it perpetually harder for median earners to buy in. It's a powerful example where just because the tech allows something doesn't mean it's automatically a societal good. We need prudence.
Okay, we have covered a ton of ground today. It's clear that DePINs are doing something really fundamental using clever token incentives complex proof mechanisms like proof of coverage or those node purchase models to basically pull real-world services and infrastructure off of purely centralized control.
Yeah, the core idea is that shift, isn't it? Moving people from just being passive consumers of vital services
Mm.
to potentially being active co-owners,
Mm.
stakeholders, whether that's contributing to a global map, offering up cloud storage, or participating in a local energy grid.
And the long-term vision here, the ultimate value,
Yeah.
it seems tied directly to whether these networks can actually deliver on that promise of more resilient, maybe more equitable, and definitely more efficient societies.
I think so. DLT isn't just about digitizing things we already have. It's genuinely enabling new ways for communities to own and manage assets together. It allows for new market designs where maybe people can choose the economic systems they participate in, somewhat independent of traditional top-down governance.
And the timing seems right too, doesn't it? With the explosion of AI creating this insatiable demand for data, for compute power, that feels like a strong tailwind for DePIN.
It's a massive tailwind. AI needs vast amounts of diverse, high-quality data and distributed compute. DABINs, focusing on that kind of vertical, specific data extraction or resource provision, seem perfectly positioned to complement the big horizontal data lakes of the traditional centralized players. There's room for both.
So wrapping this up, what's the final thought for people listening?
Well, I think the really revolutionary thing here, under the hood, is how this technology drastically reduces the coordination costs that historically made building and maintaining shared infrastructure so difficult and expensive.
Right, like that shared EV example. DLT makes the previously impossible possible.
Exactly. So if these technologies can slash those coordination costs, the question for you listening becomes, what kind of new ownership models, public or private, could you imagine building? Starting right in your own community, what problems could this solve where you live?
And maybe just as importantly.
And just as importantly, reflecting on that housing example,
Right.
what are the ethical boundaries? What are the limits to the kinds of ownership models we should be building with technology this powerful? Where does efficiency potentially clash with other societal values? That's something we all need to think about as this evolves.